Assalamualaikum warahmatullahi wabarakatuh and good day. I'm Anissa Maisara binti Aziz, S56441. I will be presenting my final year project titled Review on Environmental DNA, DNA Analysis for Biomass Assessment in Fish and Aquatic Organisms with the supervision of Dr. Nur Asma binti Arifin. Environmental DNA, EDNA has shown to be an effective method of identifying marine and freshwater species since it does not need the collection of wild individuals, and EDNA-based approach for fish inventory or detection is less intrusive compared to other sample methods such as electrofishing. As a result, employing EDNA is less stressful for individuals and environmentally friendly. Apart from that, it is less expensive and time-consuming compared to traditional methods, and it has a higher detection rate as well. The problem statement of this study is the fishery independent surveys are often costly and logistically demanding compared to EDNA analysis. Direct capture removal, bycatch mortality, habitat degradation, noise pollution, and ghost nets and traps all have an influence on marine fish populations. Lastly, bottom trawl surveys, which are essential for monitoring marine fisheries, take time and are limited by cost, environmental damage, and the inaccessibility of some areas. For the significance of this study, environmental DNA, EDNA technology has the potential to improve marine fish population monitoring. EDNA analysis eliminates the requirement for the instruments and time necessary for animal dissection and tissue collecting. Molecular approaches have demonstrated their ability to trace historical patterns of species distribution, population dynamics, ecosystem health, and trophic interactions. The objective of this study is to determine the current status of EDNA analysis for biomass assessment in fish and aquatic organisms. The methods of this review begin with data mining, followed by references classification, data tabulation, and data classification. For data mining, the keywords used to find the articles include EDNA, environmental DNA aquatic, EDNA biomass, EDNA fisheries, EDNA metabarcoding fisheries, and metabarcoding biomass. These keywords are searched on websites such as Wiley Online Library, Web of Science, Google, Google Scholar, ScienceDirect, and PubMed. For references classification, these articles are saved according to their authors, year of publication, and followed by keywords important in the articles. Then, these files are saved in a folder named references. These data are then classified based on their year of publication, country, species studied, biomass assessment and techniques used, and full access to articles. Results show that 86 papers have been assessed for biomass estimation in fish and aquatic organisms, where only 22 of them discussed about it. Meanwhile, 21 papers discussed about a particular species that has been assessed for their biomass estimation, and most papers only reviewed environmental DNA and discussed about it in general. There are a few that talk about biomass estimation in non-aquatic species, such as amphibians and mammals. There are also a few papers that discussed the biomass estimation of fish and aquatic species in a particular environments such as river, streams, ponds, lakes, and aquarium. Among these articles regarding environmental DNA, 17 come from Asia, 16 from North America, 2 from Oceania, 3 from Europe, and 1 from the Pacific Ocean. DNA is mostly used for invasive species detection and abundance estimation. The most frequently used method for biomass assessment is EDNA metabarcoding. Table 1 shows the 22 articles discussing about biomass estimation by their study, environment, techniques used, and their results. While being less intrusive, time-consuming, and expensive, EDNA expands the geographic and temporal coverage of population evaluation and monitoring. It can help speed up sample collection, reduce data collection expenses, and protect the species under study from harmful consequences. It also offers a lot of promise in terms of helping in the resolution of technical issues related to sampling in remote locations. It is environmental friendly, and the trend is increasing for biomass and abundance estimation, and EDNA metabarcoding is faster and frequently used for biomass assessment. The quality of the sample, the building of DNA libraries, sequencing procedures, and bioinformatics analysis all have a role in the data's dependability. Temperature, UV, light intensity, and oxygen content all influence EDNA persistence and degradation, which influences microbial action and metabolic activity in aquatic species. EDNA can settle out of suspension under stagnant circumstances, but it can be reincorporated into the water column after sediment aggregation. Ponds are also impacted by domestic and wild animal activities, which can increase suspended particles in the water column and alter the characteristics of an EDNA sample. External factors have the ability to transport EDNA between water bodies, resulting in false positive detections. The capacity to identify present from recent or historic presence can be harmed by EDNA buildup. In conclusion, from 2012 until 2021, the trend in EDNA analysis for biomass estimation is increasing, especially in Japan. EDNA analysis has been used for many assessments such as biomass and abundance estimations, species identification, and invasive species detection. Environmental DNA is mostly used for invasive species detection and abundance estimation. Therefore, it is suggested that EDNA be developed as a complementary method for measuring population abundance and/or biomass across different species of fish in both freshwater and marine habitats, assuming that all parameters are taken into account and standardized. These are the references referred in this proposal with 87 references in total. Thank you to coordinator, supervisor, and